All right, in this video, we're going to be looking at the worksheet in your homework packet that says Worksheet H that's supposed to be done in groups. So you guys will be working on these in groups, but this is one that we're going to look at together just so you get an idea of how to approach these problems. Now, these are going to be taking real-life story problems that are periodic in nature, where they repeat themselves, they follow a pattern that repeats themselves, and so they can be graphed, and it would be sinusoidal in the sense of it would look like a sine wave if we were to graph it out. So we're going to take this information and see how we can create a graph and how we can create an equation to model this scenario. So it says a paddle boat water wheel with a 7-foot radius has 1 foot submerged in the water as shown and rotates counterclockwise at 5 revolutions per minute. A bug is sitting on the wheel at point B. You start your stopwatch, and 3 seconds later, the bug at point B is at its greatest height above the water. You are to model the distance h of the bug from the surface of the water in terms of the number of seconds the stopwatch reads. All right, so what that means is that our goal is to create a graph. So let's go down here. And on that graph, we're going to have time be the x-axis, and that's going to be in seconds. And the y-axis will be your height, and that would be in feet. So that's going to be the height that the point B would be. That's where the bug is, the point where that bug would be after a certain period of time. So how far above the water that bug will be. All right, so let's see what we can figure out here. So there's some things that we want to find from our graph. We want to find out, like, what's the maximum point of the graph, what's the minimum point, and how has it been shifted horizontally, what's the phase shift, what's the vertical shift, what's the period, all those things that we've been talking about. So first, let's figure out what the maximum height would be. Well, it says here that or you can even look at the diagram. So when we talk about maximum height, we're talking about maximum height above the surface of the water. The radius is 7 feet, and there's 1 foot of it below the surface of the water. So that means from this point to this point is 7 feet, and then from the center down to the surface of water is 6 feet. So if we add those together, we get a maximum height above the surface of the water that the wheel is going to reach is 13 feet. The minimum is going to be 1 foot below the surface of the water, so we'll just represent that as -1. All right, so for the purpose of our graph, let's find some other pieces like the amplitude. Remember when we were finding the equation and we had graphs like this? And I said one way that we could find the amplitude is we could find the distance between the highest and lowest point and divide it by 2 or cut it in half, and that would give you what the amplitude is. So we can use that same concept to help us figure out what the amplitude would be in this situation, because we know that the highest value is 13, so the maximum is 13. So we could subtract that from the lowest value, which is -1, and then take half of that. So 13 minus -1 would be the same as 13 plus 1, which is 14, and 14 divided by 2 would be 7. So the amplitude is going to be 7. The period is how long it takes to repeat itself. And so there's some things here that help me figure out what the period would be. So the time it would take for 1 revolution of the circle. We can get that from right here. So we know that there's 5 revolutions in 1 minute, or 5 revolutions in 60 seconds. So if we divide that, 60 divided by 5, we get 12. So that means it's 12 seconds for every revolution. All right. So we're going to use that information now to help us answer some of these questions. So again, the amplitude, we found that to be 7 feet already. The period, so now the period is 1 revolution is 12 seconds. So we can use that to figure out our B value when we go to figure out our equation. So remember, the B value is always 2 pi divided by the length of our period, so 12 seconds. So if I reduce that, that reduces to pi over 6. So when we get to that point where we need to find what our value for b is in our equation, we know that's going to be pi over 6. The vertical shift is how far up it's been moved. So that would be, in this represents where's the center been moved to. The center is not centered around where the wheel is equally above and below the water. Okay, if that was the case, it would be centered at the x-axis, but it's been shifted up where the center now is 6 feet above the water. So only 1 foot is going below the surface of the water. So 6 feet up, positive 6 feet, would represent the vertical shift. All right, now let's think about this. This is the phase shift is where it gets a little tricky. To determine the phase shift of the graph, you need to know a high point, a low point, or a middle point relating to the problem. Here we know a high point. Okay, so we know the highest point that the bug's going to reach is 13 feet. Or the highest point the wheel is going to reach is 13 feet. And we know that it didn't get to that point until 3 seconds after we started the timer. Okay, so if you go back and read this, it says the bug is sitting on the point B. That's where the bug is at when we start our timer. And 3 seconds later, the bug is up here. So we're not starting at 0, we're starting 3 seconds afterwards. So when we get down here, our highest point is going to be first measured after 3 seconds. So since we know the highest point, that would be based on, so the cosine function is a situation where we would be basing it on the highest point. If we're basing it on a point on the midline, so like let's say if it's a situation where we knew where the bug was at the surface of the water and the travel like that, then we would base it on the sine function. So here, since we're basing it on a high point, we're going to use the cosine graph, base it on the graph of the cosine function. And like I said, the phase shift will be 3 seconds. Okay, so we're going to move that cosine function to the right 3 seconds. So that's what I just did there. All right, let's put it down some of the other key points. So we know that that high point is going to repeat itself again after 12 seconds. Remember, the period is 12 seconds. So I'm just going to count by threes here. So 3, 6, 9, 12, 15, 18. All right, so 12 seconds later, 12 plus 3 would be 15, so it's going to repeat itself after 15 seconds. So another 15 seconds later is when it repeats itself. Now the horizontal line, the midline, is going to be it's going to be shifted up 6 units. Let's put 6 here. Okay, so that'd be our midline. And we know the lowest point is going to be -1. Now, when does it reach the lowest point? That's a good question. When does it reach the lowest point? Well, it's going to reach its lowest point halfway between 3 seconds and 15 seconds. So 6 seconds later. So remember, this is 12 seconds is one period. So halfway around would be when it's going to be the lowest point. So it'll be its lowest point right here, right on the 9. That's where it's going to reach its lowest point. So we have enough information now. Where we can sketch a graph of that line. So that's really all we need to be able to sketch a graph. So now we can come up with some equations. So now remember, we're basing this right now on the cosine function. So let's start there. Let's start with the cosine equation here. So our amplitude, we found at the beginning, our amplitude was 7. And we're basing this on the cosine. And our b value, remember, we found that to be pi over 6. And then it would be x minus our h value. So remember, we said that our h value was 3 seconds. It's been moved to the right 3 seconds or 3 units. And then it moved up 6 units. So that would be our equation if we were basing it on the cosine function. Now remember, we could also do a sine function. Whoops. There we go. All right. So if we were to go backwards in time, or before we started the timer after 3 seconds there, so the height at the very beginning the bug after 0 seconds, we can see here, would have been 6 feet. And so if we wanted to come up with a sine function, it would still have the same amplitude of 7. And then in this case, again, the b value would still be pi over 6. But if I'm basing it on that part of the graph, there's no horizontal shift, so it'll just be pi over 6 times x, and then plus x. Now technically, we could have came up with a different sine function. We could have done a sine function here, which would have been flipped vertically, or we could have gone and created a sine function that'd be here, which isn't even on my graph, but I could have come up with a sine function there. So there's a lot of sine functions that we could have created. So now we're going to use either one of these equations. This is how far from the water is a point after 5.5 seconds. So again, x represents your time in seconds. So we're going to put 5.5 in for x. And if you put 5.5 into either equation, when you get the same exact answer, just want to make sure that your calculator is in radian mode, because everything's in radians here. If you typed it in your calculator, you end up getting approximately 7.8 feet. Again, it doesn't matter which equation you use, both equations result in the same answer. So that's how you do that first question in your assignment. So now the other ones are not going to be the same type of problem, but they're going to be the same concepts, where you're going to be looking for, even if they don't ask for it, you want to look for these values. You want to figure out what's the maximum value, what's the minimum value, what's the amplitude, what's the period. And in addition to that, I didn't write down vertical shift or phase shift because they asked for it here, but if they don't ask for the vertical shift and phase shift, add that, find those pieces. Once you find all those pieces, that's going to be enough for you to be able to sketch a graph. All we need for the graph is where it starts and ends at, and what's the highest and lowest point, where that midline is, and that's going to be enough for you to be able to come up with an equation, and then use that equation to make a prediction. So good luck now as you work on questions 2 and 3 in your assignment.